understand what other things will be there. Those who have already worked in quadcopter, just you can go through and then you can add some more points on that. Okay, it will be help to our friends. Okay, so quadcopter frame is the first one. It includes arms to hold motors and the chassis to hold the flight controller, battery, and other stuff on the board. Okay, that is the thing. And then it's made up of various materials. The present out there are plastic, glass fiber, carbon fiber, and aluminum. Okay, it depends on the applications. You can select it because you know that the aluminum is the low weight and also it's a high strength material. So it depends on the applications and the need. You can design the material and you can do it. And recently, some of them they started with the composite also, as like mentioned here. So we can find our own material to fabricate them. And there are two types of configuration generally follow. Okay, one is plus configuration and cross configuration. By seeing the pic, you will understand that what is plus and what is cross configuration. Can anyone say that what will be the advantage of these two configuration, cross and plus? Those who worked in drones or quadcopters. Which profile will be better, inclined profile or straight profile?
So depend speed and stability will differ in both.
Exactly, that is true. Another one.
Directive control will be better on the cross configuration.
Okay, good. Okay, did you operate both the things? How the movement of the vertical will be in a plus and cross configuration? Okay, it's a small question actually. The movement based on that, okay, you can search it on in Google. Based on the movement, you know, the horizontal, vertical, incline, and then rotation. Okay, which configuration will be better? Just think about it. Okay, just to Google it and then find out the solution of that. Okay, which one is better than what aspect? Okay, next one is motors. So in quadcopter 4, motors are must for quadcopter to lift it up, and motor should be powerful enough to allow flying. That one we have to do calculations. So some of the kinematics are there. Those things we will see in the next class. Okay, kinematics. And then the motor speed rated in kilovolt, you know that, and then the RPM of the motor varies with the kV rating and its input voltage. Okay, can anyone suggest that what kind of motors you used? What is the
brushless DC, sir?
Very good, brushless DCs. Okay, what is the advantage of that?
Less weight, more power.
Less weight, that is one. Okay, okay. Because of
More power to weight ratio, sir.
okay. Am I audible now?
Yes, sir.
Yeah, the headphone I was using, I think so. Okay, so power to weight ratio is okay. What is the advantage of brushless motor? There is power to weight ratio. What is happening in brushless motor? Because maybe our friends also will understand. What is brush and then brushless? What is the advantage of that?
Sir, the stator is constant.
Exactly, because of that, what will happen to the motor? Because we are studying, right, electrical engineer, electric motors, we are studying that. What is the lifespan of a brush and then brushless motor? Okay,
Brushed motor have shorter lifespan than brushless motor because they have a physical contact.
exactly. Because of that physical contact, what kind of forces will be created? There will be a friction. Because of that,
Heat will be generated.
exactly, because of the heat will be generated. Because of the heat, the system may be affected soon. Okay, that is the thing. So when you are studying that components also, please go to that fundamental. Thanks a lot, boy. What's your name? Sorry, I couldn't get your name on the screen. What's your name?
Niche.
Anish. Okay, thanks a lot. So when you are studying that, why we have to use brushless, what are the other types of motors are there? All those things we have to study. Okay, that one. Okay. Now nowadays we are using high torque motors. Okay, that's the thing. For a lift, drag, all those movement. Okay, fine. And very important thing is electronic speed controller. Nowadays we are using it. Okay, it's an electronic circuit which is used to change the speed and direction of brushless motor. And one more thing is AC converts DC battery power into three-phase AC for driving brushless motors. It is the interface between the motors and the flight control. Okay? It will look like this. Just so you can note it down that interface between the motors and flight controller is done by ESC. And one more thing is the speed and direction of brushless motor is changed by using ESC. Okay. Anything else you can add with this? Those who worked in the drone, any other points we can give for electronic speed control?
Sir, each motor has an individual ESC.
Yeah, very good.
Sir, we have to give a PWM signal into, we have to feed the PWM signal into the signal pin.
Exactly. That is also, so the PWM means they have to know that pulse width
Modulation.
Yeah, signal also. Okay. So these are the advantages of this electronic speed controller and how it has to work. Okay. Please, I will share the video. Those who are not listening and those who are having some other work meantime. Okay. Please watch this. That will be useful because the people, those who are working in drone are also in our value added program. They can give an additional input than whatever present in the slide. Okay. So next one, very important one, propellers. Okay. So if you want a propeller and finding its property, whom you will contact? You will contact mechanical engineer or electrical engineer or electronics engineer or computer science engineer or robotics engineer.
Mechanical engineer.
Mechanical.
No, please, hereafter you say that robotics engineer. Okay. Because you should have a knowledge of all these things. How much angle it should be twisted. Okay. So for that only, we are teaching you a simple FreeCAD. Okay. Maybe if time permits, I will teach you one propeller design in SolidWorks, if time permits. Okay. Because within 32 hours, we cannot give everything or we cannot feed that much. Okay. Possible. Otherwise, I will take one research paper and then I will explain about the propeller alone. Okay. That will be better. So one of the most important parts in the drone is propeller. The very part that creates the airflow that lifts your machine into the air. Please underline this. Your entire flight is depend on this propeller design. Okay. And it is also having various material. And then thickness and then the twisted angle. All those things you will see in detail later. Okay. Can anyone say what kind of propeller you used? What is the size?
12 inch.
12 inch, very good. I have used 12 inch. Thickness? You didn't measure, I think so. Okay, fine then.
1245.
Okay, good. Okay, fine then. Okay. What is the maximum speed it can go? Did you check in the specifications?
Sir, actually, I am rotating it at 7,000 RPM.
Oh, 7,000. Okay, fine.
Yes, at max speed.
Fine. So we gone up to 2,000 RPM only, just to move from one place to another. Okay, fine then. Good. Okay, so the next one is flight controller. So its function to direct the RPM of each motor in response to input. And one more thing is the command from the pilot for the quadcopter to move forward is fed into the flight controller, which determines how to manipulate the motors accordingly. Please underline this word. The manipulation is purely done by flight controller. So various companies are manufacturing this. Okay, which one is used to us? We can buy that and then we can operate it. There is up, front, roll, pitch, yeah, everything we can do by using this control. These are fundamentals about quadcopter. Next one is very important thing. Okay, here only we will face a lot of issues. Okay, we will keep on operating, but the system won't respond. RC transmitter and the receiver. Okay, so radio transmission is an electronic device that controls the quadcopter manually. It is a remote controller which used to control altitude, speed, the orientation of the drone. Okay. This control should be effective, otherwise the drone will fail at any time. Fail in the sense fall at any time. All these things are readily available, but anything before you are going to do the actual experiment, we have to check. Okay. As like one of our friends said, 7,000 RPM, all those things you have to check whether conditions, all those assemblies should be done properly. And each blade we have to rotate and then we have to check whether it is functioning properly or not. And the transmission and the receiver also, with the device, without the device also we can check. Okay. That's okay. So what we used to do means we used to carry this transmitter and keep it on top of the building. And then from the room, we will try it out, how much cover it is coming, whether it is giving the signal up to first floor or second floor or third floor. We used to check like that. Okay. The transmitter and receiver. According to that, we will find out the height, up to how much height it can or how much distance it is receiving and transmitting the signal. Okay. Next one is very important one. Because of LI lithium batteries, we have achieved this actually, I can say. The power source that drives all the system on the drone that allows it to fly. And the battery is the single heaviest component of the drone. This is the main thing. So bigger size battery doesn't mean it will fly longer. Please understand this sentence. Okay. Bigger size battery means it doesn't mean that it will fly longer. So anyone else who use different types of battery? We have
Yes,
used
sir.
lithium. Anything else?
Sir, I have used 5,200 milliamp hours
Oh,
4S battery.
how much it cost actually for you?
It cost about 6,700 rupees.
Okay, 6,700, right? Okay,
Yes, sir.
okay. What is the lifespan they put actually? The storage.
Sir, actually, it depends on the charge cycle.
Yeah, that's only I'm saying that. How many times? Because they will also come to know how many hours it will withstand actually. If suppose
No,
I
sir, actually, I have not researched about that.
okay,
I didn't know.
that's good actually. That's good because you
Huh?
bought it. Actually, generally, what you have to do after charging for everyone, I'm saying that after charging it, we have to check that how many hours it is running. What we did is after taking one battery, we connected with one single blade rotor, and then we made it to run for an hour. Okay, so it gave around 2 hours exactly. So based on that, we have checked the efficiency of the battery. These are trial and error. We have to check the specification of the battery always. Okay, even
Yes,
though
sir.
it is okay, those kind of initial checking we have to do it in any kind of product what we buy. Okay.
Sir,
Yeah, please tell me.
sir, at VIT, have anyone tested with experimental battery technologies like solid state batteries?
Well, those things we are working on that, but we are not having a lab. Yeah, can you please repeat the question so that I can ask in the faculty group and then I will let you know.
So have
Solid.
VIT tested solid state batteries?
Okay, solid state battery. I will inquire.
Solid state batteries.
Yeah, understood.
Yes,
Solid state
thank you.
battery. Okay, any person are working on that. Am I right? Sure. I will check it out. Okay. I'll check it out and then let you know before this VAP. Okay.
Hello, sir.
Yeah, please tell me.
Actually, I have one doubt, sir, in bat regarding.
Yeah.
So, when you have said that you have driven the motor for like 2 hours and it is withstanding
Yeah,
for
2
2 hours.
hours. Yeah. Yeah,
If it will actually change, sir, like say if there's so much drag in the air, if the airflow is very high, if the speed of air is very high, it will change.
Exactly. What's your name actually? What's your name?
Faraz, sir.
Anas. Yeah, exactly. What you said is correct. So we have checked in the known environment. Are you getting? Okay.
Okay, sir. Okay, sir. In a closed
2 hours.
environment, like in a room or like
Yeah,
that.
exactly. In a room itself, only 2 hours means. In an open space means how much time it will work.
So it will definitely
One
get
by
ready.
1/4.
Maybe I think so. I haven't tried that.
Exactly. So what we tested is we tested our this one. What is the battery? Okay, only for 10 minutes because you know that we used 4 rotors.
Yes, sir. So we
Okay,
had
so
divided by 4.
yeah, exactly. So they said that it will long for more than 5 hours. Got it? But
Okay,
in a
sir.
practical condition, when we tested, it came only 2 hours. And we tested our drone for only 10 minutes. Got it, boy?
Okay, sir. Okay, sir.
Okay, so any device, whenever you are purchasing it, please check this kind of initial check. Okay, that is important in developing any kind of unmanned vehicle. Okay, aerial vehicle or any vehicle, any component you buy, please check their specification, what they said, what it gives actually. Okay, that's it. Okay. Okay, now we will come to the flying mode. Okay, how drones are flying with a simple video.
An aircraft is an amazing machine, capable of flying in any direction by rotating about in 3 dimensions. These are called axes of movement. The average location of an aircraft's mass is a point that is called the centre of gravity. So if you suspend an aircraft from the centre of gravity by a line like this, the aircraft remains perfectly balanced. Each of the 3 axes moves about the centre of gravity. The aircraft's principal axes are normal axis, drawn from top to bottom, lateral axis, drawn parallel to the wings, and longitudinal axis, drawn from tail to nose. Each axis is perpendicular to the other 2 axes. Let's look at each individually. The rotation about lateral axis is called pitch. This movement changes the vertical direction of the aircraft's nose. The rotation about normal axis is called yaw. This is the movement of the nose of the aircraft from side to side. The rotation about the longitudinal axis is called roll. This is the movement of the aircraft's wings. One wing goes up, the opposite wing goes down. So in summary, these are the 3 principal axes of movement.
Yeah, any doubt in axis of movement? You can ask me so that I can clarify here itself. Or shall we proceed?
So drones, do they have this thing? Yeah, that. Sorry,
Everything. Everything, it depends on how we are controlling the rotor, you know.
Okay, sir. Because I have seen this in plane. Plane have this back tail. So based on that tilting of that blade, it will move left or right. Plane can change direction. And drone,
Exactly.
it
Anything it can be controlled with the speed variations of the rotors. Okay.
Okay.
So
Sir.
general question now: if I want to move the rotor, that is rotors left and right, or okay, according to that, if I am varying the speed, according to that, there will be an inclination. Am I right? One is high,
Yeah,
another
yes,
one
sir.
is low. Yeah, similar to that, yaw movement also can be done. Okay, we have done that. And one more thing, general question I want to ask from this slide is: if I want to move the drone up and down, which one I have to control? Pitch, yaw, or roll?
It's pitch.
Pitch, very good. So if I want to rotate the drone with 30 degree, which one I have to use? Pitch, yaw, or roll?
Sorry, yeah.
Yeah, sir.
30 degree rotation.
Rotation in the sense it is rolled, sir.
Roll, yeah, exactly. Rotation purely it will come in terms of roll only. Okay. If I want to move the drone left or right, which one I have to control?
Yeah.
Yeah,
Yeah,
very good.
sir.
Both,
Yeah.
maybe the combination
Yaw
of
and
two
roll, sir,
sometimes.
both.
Yeah, exactly. That's correct. 100% correct. Okay. But when I'm saying 30 degree rotation means the entire drone I am rotating, not the movement. Hope you got it. I think so. That's only roll will play a major role. Okay. The complete rotation is depends on the longitudinal axis. Okay. So based on these things only, any unmanned aerial vehicle will fly. Okay. So please take a note of this: pitch, yaw, roll. So depends on the operation. For example, if I am giving a condition in our institute or in any one of your institute, I want to design a drone. Okay. And it has to go and then do your security surveillance, and then it has to come back. Okay. What kind of movement you will use it? Whether you will use only pitch, or whether you will program only yaw, or whether you will program only roll.
I mean, it has to do a loiter. It has to cover a large region. Means it has to go and loitering somehow in the air, and then it has to come back. Means
Very good.
different applications will be there. Not
Exactly.
one.
The thing is, role is simply it's like our CCTV camera. Are you getting 360-degree? It will monitor. Yeah, it will monitor only in left and right. Which will monitor only in up and down. Okay. When you are having a quadcopter with all these features, with the forward movement and lateral movement, all those things, then only it will cover all the things. Okay. So when I want to check who is down, I can go for pitch. Okay. When I want to see what is there in the left and right, I can go for yaw movement. And if I want to capture the 360-degree environment, then I have to go for roll. Am I right?
Yes, sir.
Yeah, so that's the thing. Okay, so it depends on the applications we can use this. Okay, this is the fundamentals. You have to know about this very well. Okay, and vary the speed of the rotors, as I told you, to control the position and orientation of the robot. Please make a note. So here only your intelligence playing a major role. All the algorithms, codings are playing a major role in varying the speed. I think one of our friend is worked in quadcopter already. I think so. How will you control the vary the speed, boy, if you are not having a manual control, if it is autonomous? Did you work on this
Yes, sir.
autonomous?
By using motor mixing algorithms.
Yeah, exactly. Which algorithm? Can you please say?
It is commonly called as motor mixing algorithms.
Exactly. Okay, fine then. Okay, those algorithms you can use. You can vary the parameter. Am I right? For
Yes,
the known
sir.
environment.
For example, if you want to lift it up, means all the 4 motors has to be rotated in the same speed. Each
That is
pair must
already
be in the
there. That is,
opposite direction.
yeah, that is already there. That is correct. Yeah, you explain so that our friends also will understand. All the 4 motors, if it is vertically up, that is correct. Okay. If I have to move to the left means.
If you want to move it to the left, means it depends upon the configuration. Either it is a plus configuration or cross configuration. Every pairs, for example, 2 motors will be rotated in the clockwise and other 2 will be rotating in the counterclockwise direction.
Exactly. Okay.
So
According to that, which side it will move, clockwise or counterclockwise?
That depends upon the direction of movement of the motors. For example, if the counterclockwise motor rotation is somewhat higher than the clockwise rotation, means then the entire motor will move in the clockwise rotation direction.
Exactly,
That is,
you're right.
which motors are moving slower, in that direction only the drone will turn.
Yeah, please make a note of it. Actually, I thought of saying you said everything. Okay, based on the speed only, the direction, everything is achieved. Okay, fine then. So if I want to tilt,
In the sense of forward move, that is maybe, for example, cross configuration means in the front we are having 2 motors and in the back we are having 2 motors. The front rotating 2 motors speed will be somewhat reduced. Then automatically the quadcopter will pitch down.
exactly, good. So likewise, we can adjust left, right, up and down, everything. Okay, if you want to go for
Yes,
up, very good. So all those things, what I want to explain, already our friend explained actually. That is one thing. And one more thing is where we will face a problem is the speed control. Okay, one motor may run at a greater speed, another motor will be at average speed, and another motor will be low speed. So when you are selection of motor, whenever we bought 4 or 8 or anything, okay, we used to buy minimum 12, okay, for one set of applications. In the 12 also, 3 will be in the same configuration, remaining 9 will be in some other configuration, so that we have to do some tuning in that, and then we have to bring it to the actual speed. Otherwise, we have to operate a certain thing, motors. For example, one of our friends said 7,000 RPM he has a drive. Okay, when we have purchased for 10,000 RPM, actually, we are able to achieve only 5,000 RPM because all the motors are okay up to 5,000 RPM. Okay, so practical difficulties also there. Okay, according to that, we have to program and then we have to execute. Okay, that's the thing. So based on the speed control, the directions also can be achieved and orientation also can be achieved. That's only I want to convey from this slide. Okay. Okay. Roll and pitch. Just now we have seen. Okay. Just I can read it so that you will get it much better. Okay. So plus configuration drone is shown in the front view. When the left side motor speed is increased and the right side motor speed is decreased, the drone can be tilted to the right side. Please note it down. Basics. Okay. Anyway, I'm going to give the PPT in PDF. You can use it. Okay, can I move to the next one? Any doubt in this?
No, sir, no doubts at the
Okay,
moment.
fine then. Okay, those who worked it will be easy. Though those who are learning newly, then you have to understand. Okay. And next one, roll and pitch. When the right side motor speed is increased and the left side motor speed is decreased, the roll can be tilted to the left side. Fine then. Next one. Okay, these are the things. Please take them. Actually, technically, if you are talking vertical motion, is covers hover, climb, and then descent. Okay. To hover means the net thrust of the four rotors pushing the drone up must be equal to the gravitational force pulling it down. Please underline that. Should be equal to the gravitational force pulling it down. Okay. Can you tell me the gravitational force? How much it is? Anyone?
9.8, sir.
9.81. In what is the unit?
Meter per second.
Meter per second square.
Meter
Per second square
Yeah,
acceleration.
exactly. Good. Are you people are calculating? Any design calculation? Are you doing or simply you are buying the components and assembling it and make it run? Both the ways, sir. Okay. I will take it in positive. Sometimes you are calculating, sometimes you are assembling and it make it run. Okay. So next very important thing, climb, increase the thrust, that is speed of the four rotors so that there is a non-zero upward force that is greater than the weight. Please underline that word. It should be greater than the weight. So three forces on the drone are weight, thrust, and air drag. I am sorry, I forgot to say about this definition. Can anyone say what is drag? Because I don't know whether everyone knows the definition of drag.
So when a body is moving through a fluid, the fluid exerts a opposing force.
It's opposing force. Very good, actually. It's opposing force that is called as drag. Okay. If a vehicle wants to fly means whether drag should be more or less.
So less.
Less. Very good. You can find that. So we have to give the force more than the drag or less than the drag to fly in a forward direction.
Excuse me, sir.
More, sir.
Yeah, more. Exactly. Yeah, please tell me.
Sir, can we say that air drag is like friction force, but in air?
Yeah, that is also correct only. That's true. Because the vehicle is causing friction. Am I right?
Yes, sir.
Yeah, that's the thing. And the thrust, can anyone say the thrust? It is a force required to?
To move a body upwards.
Yeah, it's not. It's to move a body, okay, in a space. Okay, here in unmanned aerial vehicle, whether thrust should be more or yeah, drag should be more. If I want to park a vehicle,
Thrust should be.
So to park, drag should be more.
very good. If I want to park, drag we need. If we want to fly, which one should be more? Thrust should be.
Thrust should be more.
One general question, actually, I got it from IIT professor. Actually, what is the relationship between the speed and the drag? Any relationship is there?
So as the speed increases, the drag increases.
There is general. Any mathematical relation is there?
Squared, sir.
Very good boy. Who is that?
Anand.
Wow. Okay. Thanks a lot. Okay. Recently, I went for one workshop. Okay. There he asked actually. Luckily, we have said the correct answer actually. Square. It should be square of that term. Okay. Next one is descent.
So what should be square, sir?
What is the mathematical formula?
Yeah, it is available, right?
So the drag force is equal to half rho L V square.
Exactly. Correct one. Can you please repeat so that they can write it down also?
The drag force FD is equal to half into coefficient of drag into L into V squared.
Yes. So what he asked is, what is the relationship between drag and then speed? Okay, that's it. Okay, coming to the descent, decrease the rotor thrust. Okay, so the net force is downward. Please take that. You have to decrease the rotor thrust. Okay, so the net force is downward. Okay, fine. So these are the things related to the vertical motion. Rotation, it's very important. Okay, Just to understanding purpose, they have given in a color. So the red rotors are actually acting counterclockwise. The green ones are rotating clockwise. Okay. So decrease the spin of rotor 1 and 3. 1 and 3. Okay. Those are in green colors. Okay. And increase the spin for rotors 2 and 4. Okay. So obviously, you know that in technical term, if you have studied mechanics, it's an angular momentum. Okay. So the angular momentum of the rotors still doesn't add up to 0. So the drone body must rotate to the right side. Please take a note. So how it is moving on right side and left side, you can understand. Okay. The angular momentum of the rotors, okay, still doesn't add up to 0. So the drone body must rotate to the right side. So if you want, if you are really interested on drone, please draw the sketch also, so that you will understand much better. These things are fundamentals of UAVs. Okay. And one more point you have to note it down, that the total force remains equal to the gravitational force. And one more thing is, when we are doing this, we will have a doubt that whether it is really balanced or not. How it is balanced? Because the lower thrust rotors are diagonally opposite, so that the drone can still stay balanced. Okay, please take a note of it. And don't miss the next session, because we are having all the kinematics related. Next Saturday, expert from drone is coming to deliver the lecture about kinematics. First 2 hours will be there. After that, we can have our regular class. I thought of taking the entire session, but the 4 hours listening to the same voice is not good, I think so. You will get
Sir,
bored.
excuse me, sir.
Yeah, please.
Sir, kinematics in the sense whether he will do that equations of motions, derivations,
Exactly,
and all.
sir. Exactly. For that only I called him. Okay. Actually, he
Okay,
is
sir.
from IIT. Now he is working in one of the primary institution. So definitely
Okay.
he will cover that. What are things you want to cover? Please text in WhatsApp so that I can convey to him. Okay, sir.
Okay, sir. Thank you.
Fine. Thank you. Please, all of you, I'm saying that if you want to learn something mathematics background of UAV, just text me. I can give a consolidated topics to him so that he can focus more on that. Okay, he is working only on drones. Okay, particularly society need what it needs, he's developing. Particularly, I can say that one example is near to the seashore, when we are going to the beach, so many plastics and papers, unwanted things are there. So he is developing a drone which will go and pick the plastics or unwanted things and put it in the dustbin. Okay, so he's developing those kind of drones. Even if you are interested, you can start developing that. Okay, coming to the translation, very important. When the drone need to be moved from one place to another, it has to follow the above thing. Okay, you can actuate based on the speed control. So firstly, the pitch the drone towards the direction of the destination. Okay, and then once it is reaching near to the destination, pitch the drone opposite to the direction. Simple. Okay, so that the translation can be achieved easily. So this is the principle. Please follow that. Okay, another. Okay, so coming to this coordinate system, we are having two-dimensional, okay, original frame and rotational frame. All these things we will see in detail. Just now, you please listen to that. What are the terms are used in the coordinate system? Okay, original frame, a rotated frame, and then you are having rotational angle, and then original frame axis and rotated frame axis. Only this term you understand. Next class we will see in detail about kinematics, about all these things. Not too much of mathematics, but basics I will ask him to teach. And those who are having queries also, you can clarify with him. Then we will move to the actual design and then how to use it, all those things. This is 3 coordinate system. Rotational angle is there, and then original frame axis is coming here, and then rotated frame axis is coming. Okay, so this is the way we will mention when we are calculating the frame coordinate system, which will be useful to calculate the parameters, geometrical parameters, and also kinematics related things. Okay, kinematics means where my drone will go after certain speed. Okay, those kind of things we can calculate by using all these parameters, the speed, velocity, and then the motor, how we are driving. With the mathematical relations, we can calculate. Okay, this is the basic mechanics. Omega 1, omega 2, omega 3, and omega 4 are nothing but angular speeds of the rotor. M is the mass, you know that. Gravitational force is the G. Okay. So everyone will say that, sir, I bought a motor, sir, and then blades I have bought, everything's are there, but it is unable to lift the load. Why? Can anyone say? Most of my students used to say that. So I have bought, as you said, I have bought the motor, I have bought the wings, and then I have bought the required controller, everything. But my drone is unable to lift. Why? Can anyone say? Did you come across this kind of issues?
The thrust should be 3 times more than the weight of the drone.
A very good, valid point you have given, boy. Please note it down. We are forgetting that factor of safety. Very good. Can you repeat that? The lift should be
3 times more than the weight of minimum.
Please, he said 3 times. Please, I will say that. Please have it more than 4 times, based on the experience. Okay. The lift
So why exactly 3 or 4 times more?
Because actually, if your factor of safety is there, what is the allowable, and then what we are facing it. Okay. Because of the design, what they will say is they will say that the motor can run at 5,000 RPM, for example. Okay. But when we are checking, it may be 6,000 RPM or it may be a 4,000 RPM. Are you getting?
Yes, sir.
Okay. So because of the components, what is that? I can say that their performance, their specification, it is always necessary that whatever we are designing, it should be more than the required. Any kind of system. I'm not saying about the unmanned aerial vehicle also. Even if you are doing any kind of system, what is required and then what we are designing should be minimum 2 times greater. For example, you want to pick and place of any one of the object. Okay, you need only 1 kg. You have to lift means you have to design the mechanism or the device for 4 kg. Then only, because of the practical constraints, and then so many constraints are there, the component constraints and then specifications, it can able to lift at least 1 kg if you are designing for 3 kg. Even sometimes it won't happen also. Are you getting? Because of the physical components specifications. Got it, boy?
Yes, sir.
Okay, fine. Okay, so always more than the required we have to design. That's only one of our friends said. 3 times it should be more. Actually, I will say that please keep it in 4 times more. Because it's dynamic in nature. It's better always you can have a factor of safety or the designing of system more than 4 times. For example, I have to lift the payload of 1 kg of pesticides. I have to design for minimum 3 kg. That's the meaning of that. Okay. So 4 rotors which support the vehicle weight. Each rotor spins and generates the thrust. And then when RPM increases, thrust also increases. Thus the drag force. Okay. This is the basic mechanics of this. Please take note.
One more thing, sir.
Yeah.
Up to my knowledge, if the motor's RPM is somewhat lesser,
yes,
then
sir,
it can create more torque. Then those motors can be used for high payload application.
Sir, exactly. What you said is correct. Actually, when the motor is very good, sir. When the motors are rotating in a low speed, okay, so it can able to pull a high payload. That is correct. 200% correct. And anyway, most of the things you can see that we are working on that only. And the speed is less. There is from the practical study also we have come across that it can able to lift a large payload. Exactly. Thank you, sir. Thank you for your valuable input. Okay, fine then. So shall we move to the next slide? So these are some of the rotor speed, thrust, and then torque and the drag with speed relationship. Okay, just you can see that thrust force is there, torque speed motor characteristics are there, thrust with RPM is there. Okay, so all of these things you can know about the units, newtons. Okay, and what are the constants are there, and then momentum, all those things. These things we will see in detail when we are seeing in the kinematics and also in the control system design. Okay, all these parameters, how we are giving an input to the controller, we will study in detail. Okay? Just I want to give you the terms here alone. Okay. So this is also how to calculate motor speed. Okay, and how the weight are used, operating speed, how it is determined, and motor torques are how it is determined by using the relations are given in these equations. Okay. Maybe I can share one of the report what I'm having where we designed the drone with all these parameters. It may be an added advantage when you're having free time, you can go through that. Okay. These are the forces which are acting on the quadcopter. Okay. And we are to derive this, we need another hour. Just you can get the relations of this. That is fine. Okay. Resultant force F is equal to F1, F2, F3, F4 minus mgA3. Okay. That is based on the axis A3 is. Okay. And then resultant moment also same thing. Moment is force multiplied into perpendicular distance. Okay. So resultant moment, how we have to calculate with respect to the forces. Okay. Apart from that, moments also will be there. So rotor means 4 forces and then 4 moments we have to calculate. All these things are related to the design, mathematical related design. Okay. Just I am giving you glimpse of that. Okay, so coming to the conclusion, so in equilibrium condition, the resultant force is 0. Yes or no? Yes, I think you studied in physics, I think. Am I right? In equilibrium condition, all the net force is equal to 0.
Yes, sir.
Okay. So there will be no change in the position of the quadcopter, but when the force is not 0, the acceleration happens in vertical position as seen earlier. Okay, whatever we have discussed now. Okay, but while we are starting all these motors, actually, we will face some issues. Unequilibrium. So how to control that? Those who worked in quadcopter, you can see. We cannot actuate all the motors at a time. Am I right? Or did you actuate? Anyone? Those who worked in this area? Quadcopter? So that's only we have to do an initial test. So how we have conducted is we made the quadcopter to hang on a wire. Okay. And then as you said that in equilibrium conditions, okay, I can say that even though it's oscillating, but it's under control. We started operating 1 by 1 rotor blade. Okay. And then we have found out how much variation of angle it got produced. So based on that, when we are testing in a real time, we have controlled those rotors and then we made it to fly uniformly. Okay. Again, I'll repeat. We made the quadcopter to hang and then almost in equilibrium state. Okay. We made it to rotate each one of the motor and then which one is dominating with respect to the axis or the movement. That rotor we have controlled with less speed in the initial condition. Then we have taken the test. Okay, that's all. Now I think 3 hours passed, I think so. We can have a break for another 10 minutes.